Joint A, and I always label it. And you could call it joint A, whatever you want to call it. I always label it like that. See, so I know where I'm at. If I looked at that point, the free body diagram of that is going to look something like this. Whereas I've got an AX, which I knew what that AX was, didn't I? I've got an AY, I know that one is 3.33 kips. This is AD, right? And this is AB. The nice thing about method of joints, you don't have to worry about distances. Okay, now let's see, what did we figure out AX was? 2? Yeah, AX was 2 kips. So it's doing this. So we got 2 kips. So we've got AB. Let's see, we also have to have some kind of an angle here, don't we? So, and I do it a little bit different than the way the book does it. I like to use those angles that we've been talking about all semester. So let's see, if we've got that angle, we've got the arc, well, we got the arc tangent of 6 divided by 8. Is that correct? So this angle right here looks like about 36.9. If I can find my... Isn't that right? Because up here at the top, let's look at that, make sure, but at the top we had 6 feet, and if I can find my mouse, 6 feet right here, and then this distance given from here up to here, I believe that was 8 feet, right? So this angle would be the opposite over adjacent, right? Which is the tangent. So that's the angle for that one. While we're at it, we could go ahead and figure this one out. What's that one going to be? See, you have to have a little bit of brilliant deduction here now, don't you? How far is D? Let's see, we've got 6, and we want to come in right here with a line, right, to make it perpendicular. So we've got 6, and what's this distance right here? Wouldn't it be 3? 8 minus 5?
Wait, we're going to the right or we're going to the left?
Huh? It doesn't matter. It's 8 minus 5, right? Isn't that, this distance from right here is 8. This distance to here is 5, right? Wouldn't it just be 3? Yeah, we're looking at this little triangle.
Okay.
So it's 6 divided by 3, right? Arctangent is 6 divided by 3. Does that come out to? Okay, that looks about right, doesn't it? Not based on my sketch, but on their drawing. So, let's see, let's just put that right there. 63.4. Okay, and then we've got one more here. This one right here. What's that one going to be? 6. Arctangent of 6 divided by, what was it? 4, right? Its total's 12 minus 8 is 4. So arctangent, you're just way too fast. 56.3. That's this angle right here. And I'll show that like this. 56.3 degrees. We need to know all those so we can get them out of the way all at one time. Okay, so that's what we know. We know this angle right here, 36.9. Right now, that's all we know, isn't it? But what we could decide based on this, we could tell probably with pretty good accuracy what's going on as far as compression or tension here. We're smart enough to do that, right? Just say yes, even if you don't believe it. Okay? Now, how could we decide that? Well, look, you've got two members here that are doing something in the X direction, aren't they? They're working against this 2 kips. But we've got 2 there. So we really don't know. One of them could actually be tension, one could be compression, based on what else is going on the rest of that truss. But what we can decide out of this one is there's a force going up here, 3.33, and there's only one member in the Y direction that counteracts that, doesn't it? So more than likely, good, brilliant deduction would say that this is probably going to be compression. So I'm guessing that's in compression because it has to push back down on that thing to keep this thing static, doesn't it? Does that make sense? It's the only way we can tell. Do we really know what AD is doing? Excuse me. Not 100%. However, we do know that AB is off at 36 degrees. Some of AB is pushing down. It's not all pushing to the left, is it? So it may need some help from AD to counteract that 2 kip force. And I haven't looked far enough ahead on this problem to know what the answer to that is. That's a total guess right there. It's kind of an educated guess, maybe. But if it's wrong, guess what will happen?
We'll change the arrow. We'll get a negative number.
You'll get a negative number. Just like what we did in Chapter 4. This stuff just keeps building on itself. Nothing changes. That's why eventually I'm going to make a video book. Because nothing changes, and I'll never have to change that video. This stuff, I could use this any semester. Just plug it in and go. Because it never changes. It hasn't changed from 35 years ago when I was taking the class. It's great. Pretty much. Pretty much. It's the plan.
Yeah, do the epic montage, add the epic music in the background. You know?
Gotta slow down now. Can't hear you.
Add in the epic music in the background too, with the violins and all that stuff.
I tried that one semester and I kind of got some crap about that. I guess it was my choice of music. It was just instrumental stuff, a guitar instrumental, and everybody kind of gave me a little crap. It's an old guy thing.
Pick like music, just pick like background from music or movies. Just like do like.
Well, you have to be careful with that because if you sell it, then you have to give them some royalties.
Yeah,
See,
yeah.
so
We'll
get there. So now what I want, now let me go and, excuse me, let me go and look at point B. I'm not going to solve anything right now. I'm just drawing a free body diagram, okay? So if I go and look at point B, I'm not doing as good on my printing today. I apologize. Maybe I'm in a little more of a hurry. So if I look at point B, what's going on there? Well, I've got AB right here, don't I? Okay, and I know the angle of that. What is that angle? 50, was that 36?
36.86.
36.9. Okay, then I've got the 2 kip force there, don't I? Yeah, I've got the 2 kip force. The biggest thing you have to watch here is you have to make sure you get all of your inputs and all of your members. I also have a member going down this way. That's BD. Now that angle in there is going to, actually the angle that I want there is this overall angle, isn't it? It's this angle from here down to here. And that was 60 something, wasn't it? What was it? 60. Anybody remember?
63.4.
Was that what it was? 63.4 degrees. Then I have another member going this way, which is BC. And that angle was what?
56.3.
Thank you. And those are all relative to the x-axis, just like we've always been doing. Now, how did I know it was 63.4? Up here it was 63.4, right? And a deal if you have two parallel lines, I can get it there, then the opposite angles are equal, aren't they? So that's where the 63.4 came from. Okay. Well, we also had decided here that we're pretty sure that AB is in compression. Now, we'll know because we're going to solve for AB up here, so we'll know eventually. But we're going to say if AB was in compression on that last one, then it has to be in compression on this one, doesn't it? That was that one disclaimer I put in there. Whatever's happening at AB at A, it's still happening at AB at B. Here's what screws people up. AB is going down and to the left here. It's going up and to the right here. Doesn't matter. It's compression. You got to think compression or tension now. Okay, when we're looking at these force members. That's key. That's the only thing. You've got to remember compression. Compression always points towards the point you're looking at. And it could be anywhere in between. Later on, we are going to actually cut the member right in half. Or we're going to do a section of it, just like you would section drawing in a CAD class or a drawing class. We're going to do the same thing. Well, it's still compression there. No matter where you look at it, it's compression. So the arrow has to point wherever you're studying. Okay? So it's up and to the right here, down and to the left here. Now, we're going to leave these other ones, but because we're not 100% sure what's going on there. Could we do any brilliant deductions on this one? Not really. You really can't. It's going to be a guess when you get to that one. But what I would suggest is I probably would save that point till the very end. And here's why. Let's look at point C. See, I know a lot about point C, don't I? So if I look at point C's free body diagram, what do I have? You want to look at points that have the least amount going on. They're not busy. Okay? So point C, I've got BC doing this. I've got CY, which we know was that the 0.33 repeating? Kips. It was going up.
No, it was 167.
Oh. Actually, there wasn't a 0.33, was there?
Yeah, it was that.
Was there? So this is 0.67.
Yeah.
Okay. CX we know was 0, right? And this is CD. And we know this angle right here, what was that angle again?
56.3.
Thank you. 56.3 degrees. Then that means this one's 56.3 is right as well, right? Just in case. Okay. That's all we know right now, right? But we can probably deduce from that BC, I don't know what happened there. Get back in that. Sorry about that. BC is probably going to be in compression because it's the only thing that can push against this 6-7 in it. So it's probably going to be in compression. Well, knowing that then, we're probably going to suggest that CD is going to be in tension because BC is pushing to the right, isn't it? So CD has to pull back to the left to keep it static. That's what I'm guessing. Might be wrong. If it's wrong, it'll come out a negative answer. We'll know that we have to change it, and then you have to go back and change it anywhere it's being used. So if we find out that BC is really in tension, then you're going to have to go back here and make BC in tension. Okay? Or anything back in here. So, here we've got two unknowns. Here, we've got two unknowns. Uh-oh. It's not that bad. You've got two unknowns, kind of, if you look at the whole thing, but if you don't look at the whole thing, you don't. So we could do A or C. I'm already at C, so let's do it. Here's what we do. And this is so good because you only have forces in the X and forces in the Y. You can't do a moment because you don't have any distance. So after you get that first part done, all you have to do is worry about, the first part where you did the whole system to find reactions. All you have to worry about is forces in the X, forces in the Y. Some of you are still having problems labeling your parts so that I can see what you're doing. Need to work on that. I'm doing these like I want to see them. Okay? So if I say, I really need to see a sum of the forces in the X equals 0 equals, I really kind of need to see that because I'm the boss right now. And I would submit to you that if you're the boss, or if you're at work and the boss tells you to do something and you don't do it enough, sooner or later the boss is going to tell you one more thing. Hit the door. This way it is, isn't it? Out in the real world, thank goodness my boss never did that. Actually, he welcomed me back in the door because I did it the way the boss wanted me to. I don't call that sucking up. I call that being smart. So do it that way. So what are we listing here? Well, let's see. We've got CD going to the left, so that's a negative, right? CD plus BC going to the right, cosine of 56.3, right? Oh, two unknowns. Hate when that happens. Can't solve for that one, can I? So I come down here, I leave some space. I come down here and I do summation of the forces in the Y equals 0. So it's static. And let's see, I've got negative BC sine of, that almost popped in there, 56.3 degrees plus 0.67 kips. Solve for BC now, can't I? So BC goes to the other side of the equation, becomes positive. This stays where it's at and becomes positive, so it's 0.67 kips divided by the sine of 56.3, which equals what? How much?
0.805.
0.805. Do I have any confirmation on that? Somebody else punch it in? Let's just say 0.81 kips. Up or down?
Yeah, it's in compression.
It's not up or down. It's in compression. If it's two letters that is a member, a force member, it'll be compression or tension. If the two letters are FX or FY, it'll be up or down. Forces in the X, forces in the Y, it's up or down. Or left or right. Okay? Sorry, forgot that. If it's two letters of a force member, BC, CD, AB, whatever, compression or tension. So don't get those confused. Again, don't miss silly points on the test. If it's a force member, it's going to be compression or tension. Don't put a direction.
Compression is positive values, and tension is negative.
Nope. If it comes out a negative value, then you guessed the wrong direction. You guessed the wrong expression, maybe I should say. If you guessed it's in tension and this came out a negative value, then you would know, it's in compression. Okay, so if it's a negative value, you flip the direction or expression. Okay? Now the only place that would come out wrong potentially would be if you guessed the wrong direction on, well, no, it would have to be just, if you guessed the wrong direction on more than one force, then you would be screwed, period, because you'd have the wrong number and the wrong direction. Normally you don't see that happen. People only usually forget the wrong, they pick the wrong direction on their free body diagram, and then you just have to change it. So what, Jeff?
Same thing as normal then, you just plug in the BC to 0.81 up into the force of X.
You got it. You go up here, you plug the 0.81 in here. That was BC, right? So it's 0.81. Now CD goes to the other side of the equation. Bless you. So it's 0.81 times the cosine of 56.3. 0.4. So 0.45 maybe.
Yeah.
Kips. It came out a positive value, right? Is that correct? Okay. So CD we said was in tension, so it is in tension. And this is where I'll and I'm not going to write the BC over there. This is where I'll have that list on your quiz, and you'll be able to list all those things. And doggone it, don't put it right down in this where you're working on it here, and then go back up to that list and not be able to write it in there. And yes, I will take points off. I did this test, and I'm going to keep doing it. You got to start paying attention to detail. It's part of your world from now on. Okay? And you can call me a prick, I don't care. Just the way it is. Well, now we know BC is in compression, right? So we can put that right here. We could put that right there. And we also know the value, right? Equals, I can't remember it, but 0.81.
Yeah.
0.81 kips right here. So now we're left with A, B, and BD. And I'm still not going to commit on BD just yet. I would guess, if I had to guess right now, I would guess that BD is in compression. And the reason I say that is because you got the 2 kips and the 0.81 kips pushing to the left, and all that's working on that right now is AB pushing it back to the right. So, although, no, that's wrong. That's totally wrong. BD's going to be in tension, isn't it? Why? Hmm? No, there's an easier answer than that. I'll let you think about why. I take a sip. Why is it in tension? Don't overlook the obvious. You're overlooking the obvious.
They're both pushing up.
Say it louder.
They're both pushing up.
A, B, and BC are pushing up. There's nothing else to push it down, is there? To pull it back down. So BD is going to have to be in tension to counteract those two pushing up. As long as AB is in compression. We haven't proven that yet, have we? But that's what we're going to do. We're going to go back up to point A because we don't know. We've got 2 unknowns here. We've got 2 unknowns here, but we can kind of single out the AB, can't we? Because there's only 2 things in that y equation, AB and the 3.3. So we can solve for AB right now. Here we've got 2 unknowns, but we've got things going all directions. It's very busy. So we go to the one that's the least busy. And personally, I'd have done A first, but I was already down at C, so what the heck. So I do sum the forces in the X equals 0. Okay, and I've got 2 kips going to the right, so it's positive. Minus AB cosine of 36.9 minus AD. AD is going straight across, right? So there's no angle involved there. But I've got 2 unknowns, so I'll do sum the forces in the y set that relative to 0. I've got 3.33 kips going up minus AB sine of 36.9. AB stays here but becomes positive. Well, actually, it might be better to say AB goes to the other side and change the sign. So then we've got what? 3.33 kips divided by the sine of 36.9, right? AB equals 5.55 kips. Up or down? Thank you. Compression. Why is it compression? Because it came out a positive value. We said it was in compression, so it is, because it came out positive. Now, this is where, oh, excuse me, sorry. This is where if I had guessed the wrong direction here, it came out negative, then when I go back up to this equation where I was using AB, I would have to change it, because this force member right here would actually be pointing up and to the right, wouldn't it? It would be in tension if I had guessed it the wrong way. So keep that in mind when you're doing these. If you guess it the wrong way and you find out in this equation it was wrong, then you have to go back to the other equation and make sure you get the direction right on it. You would have to actually redraw that arrow to show it in tension. Well, we know AB now, so we'll do what Jeff said earlier. We'll just substitute that back in there. 5.55 kips. Now we're left with AD. AD goes to the other side of the equation, becomes positive. So you have 2 kips minus 5.55 cosine of 36.9.
Negative 2.43.
Oh,
2.44.
negative 2.44. Uh-oh. I didn't do that on purpose. But I didn't know, did I? Did I not tell you it was just kind of a guess?
Yeah.
So it's negative 2.44. I didn't do it on purpose, but it sure did work out that way. Which means then that AD equals 2.44 kips tension. So now I have to go back here and get my eraser out, erase that part of the arrowhead, and put it this way. That's what's really going on at AD. So that's what happens when you guess the wrong way. I did not do that on purpose. I'm glad it worked out that way.
Since you have the 3 points of a triangle, shouldn't it technically be set up like that anyway? It's a point, you have to have 1 point compression and 1 point tension so the triangle can actually snap it. So statics.
Plus you made CD go that way, so don't they have to go towards each other?
No, but you're close. You didn't say what I want to say, but you're very close. If the bottom of that truss, if I had proven that what was it, CD was in tension,
Yeah.
then AD can't mysteriously be in compression.
Yeah.
The whole bottom has to be in tension, doesn't it?
Yeah.
So I should have known that by default after I figured out what CD was. I should have gone back and said, whoa, well, wait a minute. But I was oblivious to that. It didn't matter because I know if it comes out a negative value, it'll tell me that I was going the wrong way. So I should have used brilliant deduction to figure that out, but I didn't. But at least this way it proves that that was a bad calculation or a bad guess. Brian?
So I feel like I'm missing something obvious here, and I probably am. But if AX is pushing right,
Wait a minute. Yeah, AX, the 2 kips.
yep, and we know that BX is 0 because it's on a roller. Why isn't the whole thing just shooting off to the right then? What's preventing that from happening? Just the pin? And because it's a fixed point there that's keeping the thrust from...
Well, now be careful. You're starting to mix two different things. The whole system back up here, AX is what's holding this whole system back with the two kips. But see, in this problem right here, point A, you can't, there is no two kips. When you're dealing with a joint, you're taking a magnifying glass and looking right at that point. You've got a zoom window from your CAD system, if you will, and you're zooming in on that point. You can't put forces on that do not exist in that little square. So you can't hardly mix that in there.
So the fact that it's in tension is really relevant to the two kips that AX is in.
No, well, the two kips that's going on there, it's what you would say there, I think, is since AB is actually, was it 5 something? 5.5 kips of compression. Well, with that being 5.5 kips of compression, you only have 2 kips pushing against it. It's got to have AD to help pull it back. I think that's where you would really be better off from that standpoint. But yeah, your triangle thing too, Brian, or Chris, and that's shown there on page 91, I think is what you're referring to. Well, that's actually point C, isn't it? I thought that, yeah, point A is actually, well, they don't show that, I guess, do they?
Point A is on page 93 at the bottom.
There you go. But they don't show the triangle deal.
Page 94 has the final answer on it.
Right. As far as what compression or tension is going on. Okay, so now that we know those, we know AD and AB now, we can put them on here. Well, actually, yeah, we can put them on here. So AB was 5.55 compression. And you'll really like this. So we got 5.55. I'm not going to put the kips on there. Then we found out that AD doesn't even show up there, does it? No. But what does? Oh, we still need to do BD, don't we?
AD is 2 point, that was the one we just did.
Yeah, 2.4, but it doesn't show up in point B.
Down there, yeah.
Yeah. So I was thinking we had everything found already, but we don't. We still have to find BD, don't we?
We have BC, yes.
Right. We don't have BD though. So now we would have to do. We only have to do one of these two. We either have to do the X or the Y. So we could either do a summation of forces in the X equals 0 equals. So what I would suggest you would want to do here is try to find. I've got 4 things going on in the X, don't I? I only have 3 things going on in the Y. So I could list all these. It's going to be 5.55 cosine of, 36.9 minus BD cosine of 63.4. And that's a D, sorry. Minus BC, which we know is 0.81, right? Cosine of 56.3. And let's get a little more paper here. And then minus 2 kips. Okay, so if we wanted to, you could go let's just leave that for now. Actually, we could solve that, couldn't we? Yeah, we only have one unknown, so you could solve for that. So BD goes to the other side of the equation. So you got 5.55 cosine of 36.9 plus what, 0.81?
Minus 0.81.
No, BD went to the other side. So this is, all these stay the same. Plus 0.81 cosine of 56.3 minus, or let's see, yeah, that was a minus there, so why did I change that? Sorry about that. Thank you. 36.9. You tried to talk me out of it, didn't you? Minus 2. These all stay the same. Divided by the cosine 63.4. Punch that in just like that and see what it comes out to. You do it?
4.44.
4.44. Positive, right? Kips. We had said it was what, intention? Correct? It came out a positive value, so it is intention. Bless you. Now here's what you're really going to like. If you practice these enough at home and you get good at it, you can go down there and say, okay, sum the forces into y, because you'll have plenty of time to do this, see, if you practice it. And you've got, so this now becomes 4.44. So if you list the y components, you've got 5.55 times the sine of 36.9 minus 4.44 times the sine of 63.4 plus 0.81 times the sine of 56.3. So if you punch all those in, what do you get? That should be, but you'll probably get something a little different than that. Punch it in, see what you get. Practice. Sit there and just look at me. I know I can punch it in. 0.04. So therefore 0 equals 0. You just proved that all the work you did was correct. Thank you very much. You know before you even leave that you got the answers right. Then if you say, Smith, why'd you mark that wrong? Well, you forgot to put the units in. That'll be as bad as it gets, and you'll still get 100. You won't get 100, but you'll still get an A. Because you practiced them, you did them, and you got good at this. But just watching me, I think we've proven now after 2 tests that just watching me do it and watching the videos is not enough, is it? If you're not practicing it, you're not going to do well on the test. It's that simple. That is a method of joints. The next section is, no pun intended, maybe there was a little pun intended, sections. That starts on page 94. Method of sections, it in some respects might even be easier. It's especially easier on a trust that has a lot more members on it, because then you can break what you're doing is you're breaking it down. Okay,